Okay, so this is the final part this of section 6.2. Sorry, this is kind of a meaty section, so there have to be 3 parts. So we talked about the definition in terms of x, y, and r of the 3 standard trig functions, sine, cosine, and tangent. Well, there's also 3 reciprocal functions, and the reciprocal of sine is a function called cosecant. So, and it is abbreviated CSC. Cosecant of theta is the reciprocal of sine, so it means it's hypotenuse over opposite, or in terms of the definitions, r over y. And again, that is cosecant. That's how you would spell it. Well, to make things confusing, then the reciprocal of cosine is actually secant. You would think the S would go with the S and the C with the C, but no. So secant of theta is the reciprocal of cosine, so it's going to be r over x. And again, in this case, this is secant. And the reciprocal of tangent is a function called cotangent. So cotangent of theta is x over y. So there are in total 6 trig functions, the 3 standard that you see on your calculator and you've seen before in geometry, and then the 3 reciprocal, and those are not on your calculator. So if you were to look at your calculator, you'll see a button that says like this, and you'll see one for cosine and one for tan. That is not reciprocal. That is inverse. So don't get confused by that. We will later talk about inverse trig functions. Right now, for the regular trig functions, you input an angle and you output a ratio. So in order to find, if you were to find the cosecant of an angle on your calculator, it would be 1 over the sine of an angle. So you find the sine of the angle and you take the reciprocal, or 1 over the sine of the angle. So the ratios are reciprocals. More on that later. Oh, I should probably say that COT is cotangent. Just spell it out. Okay, so let's just talk about the final type of problem in the worksheet I'm going to ask you to work through, which is to do something like the following. So say I tell you that, let's just say sine of an angle equals, say it equals 4/5. Actually, that's too easy. Let's not do 4/5. Let's say it equals something like 4/7. And I say, as in the directions here, this won't always be the case, but in the directions I'm saying this is an acute angle. So if it's an acute angle, we're going to say it's in quadrant 1, especially if it's a positive acute angle. Okay, so let's draw what is happening here. So if sine of this angle is 4/7, we've got 4 on the opposite side, or the y coordinate would be 4, and the r, or the hypotenuse, is 7. And so in order to evaluate, so the directions are saying, okay, given this information, find, and this isn't 1, this is similar to 1 on your worksheet. It's not exactly 1 on your worksheet, but the process will be the same. So the directions are say, then find the ratios of the rest of the trig functions for this particular angle. So in order to do this, in this case, we need our missing coordinate is the x. So to find x, we're going to use the Pythagorean theorem. So x squared plus y squared equals r squared, which in this case is 49. And then we have x squared equals 33. And normally, again, when you take the square root, you're going to do plus or minus. But because I'm in quadrant 1, I know that the x coordinate's positive. If I wasn't in quadrant 1, say I was in, or 4, say I was in 2 or 3, then the x coordinate would be negative. But I know my angle's in quadrant 1. So I'm going to say the x-coordinate is square root of 33. And now, since I know all the various coordinates, x, y, and r, then I can evaluate all the trig functions. So cosine of this angle, and again, I don't need to know the angle. I just need to know the x, y, and r in order to get the ratio. So cosine would be x over r, so root 33 over 7. Then tangent would be y over x, so 4 over root 33, or 4 root 33 over 33. Reciprocal of sine is cosecant, so cosecant would be 7 over 4. The reciprocal of cosine is secant, so 7 over root 33, or 7 root 33 over 33. And then the reciprocal of tangent is x over y, so it's cotangent, and that would be root 33 over 4. So again, all you need to know is it's important to know what quadrant your angle's in, because that will help you determine the sign of x and y, S-I-G-N, to figure out if x and y are positive or negative. And then you just need to know what x, y, and r are, and then you can find any of the trig functions. So so in number 17 on the worksheet, you're going to see where we're talking about an acute angle. And then when we go to 18, I make it a little more interesting because I'm telling you, well, let's do one. Actually, let's do it because it's not necessarily in quadrant 1. So this will be the last one we do together here. Okay, so let's do 18a. So 18a says the following. You are given that sine of theta is 3/5. So because I know sine is positive, which means y is positive, I know I'm either in quadrant 1 or quadrant 2. But I don't know which, and that's important because that will determine whether the x is positive or negative. But that's why I had to give you this other piece of information, that cosine of the angle is negative. So if cosine is negative, then I'm not in quadrant 1. I've got to be in quadrant 2 because we know y is positive, and if x is negative and y is positive, the only possibility is going to be quadrant 2. So I'm going to draw what I've got here. I know that y is 3, r is 5, and hopefully you remember a 3, 4, 5 triangle. If not, you can find that with the Pythagorean. It should show you that you'll end up with x squared equals 16. And again, plus or minus, because I'm in quadrant 2, it's going to be minus 4. And in this case, 18 is just asking you find sine of the angle, cosine, and tangent, so not the reciprocal ratios. We already know sine was 3/5, so cosine is negative 4/5. Tangent will also be negative in quadrant 2. Tangent of the angle is negative 3/4. So again, in number 18, unlike number 17, you have to use the given information to figure out what quadrant you're in. Draw your triangle in the appropriate quadrant, and then find the missing trig ratios. And that is it.